All right, hi everyone. Welcome to Chapter 1 from our textbook, Boundless Statistics for Organizations. I'm just going to go over a few of the concepts from this chapter to help maybe clarify some things as you go along with your readings. So you can get to the textbook one of two ways. You can either go to the textbook here on the left-hand side in this content area. If you click on the actual book itself, it'll take you to the main page, or you can click on any individual chapter. You can also go to the Learning Modules folder, and here you'll see Read, and I'll say what chapter it is you're reading. Click on that, it'll take you to the book as well. If there's additional reading, which there is this week, there's 5 essential components of the data strategy. This is a really short article, just a couple of pages. And then there is a video on Dan Bricklin, who invented the spreadsheet, predates Excel, one of the first spreadsheet tools. So let's go ahead and get to the textbook. I'm going to go through the textbook option on the left. I'm going to click on the main page so you can see here. Know that if you wanted to download the entire book as a PDF, you could click on download this book and then click on digital PDF, or if you wanted to print a copy for yourself because you would rather have a paper copy while you're taking your quizzes or exams, you're welcome to print a copy of it as well. You can even download it as an EPUB file. So if you have an e-reader like a Kindle or a Nook or one of the other e-readers, you could download that type of file as well. So whatever you'd like, but otherwise you can just click on Read Book and it'll take you right to the main page. So you can click left and right on these blue, big blue buttons on the bottom, and it'll take you through. There's a table of contents. So this is for the first chapter, Introduction to Statistics and Statistical Thinking. That's what we're going over this week. And then you'll have a kind of an overview of it. You can then, when it comes down to chapter 2, chapter 3, etc., you can click on it through there. You can also click on this drop down and it'll pull up the list of chapters that way as well. So we'll get started on chapter 1. I'm just going to click on the chapter title here, and then I'll click on overview. And again, you can click on left and right to go through it. This overview, this entire chapter 1 is all set on a single page here from all of the different learning objectives for this chapter. So you'll just need to scroll down through all of it to read all of it. You can see it just keeps going for a little while, and then eventually you get your citations at the bottom. So let's go over this first part of it, collecting and measuring data. So the key concepts are knowing the difference between these 4 measurements of data: nominal, ordinal, interval, and ratio. And then the other key point is defining between a sample and a population size. So let's start with the easy one first. Population is all units within a collection. It would be, for example, if you were doing a study on people in the United States, it'd be all citizens or all people residing in the United States. But if you were doing a study, you wouldn't be able to get data on all of those people, right? So that's quite a bit of people. So you would take random sampling or some kind of other sampling of them to represent the entire population. If you wanted to know something about how 8th graders behaved, or the average height of a NBA player, you might not take every single person in that group. You might take a sample of them. Now, NBA players, you could probably get the data on all of them pretty easily. But if you wanted to know the average height of an 8th grader in America, you're not going to be able to measure all of them. But you would take a sample of however many, ideally hundreds or thousands as a sample size to represent the entire population. But the population is going to be everyone within whatever it is you're studying, whatever that group is. All right, so let's go on to determining the difference between nominal, ordinal, interval, and ratio. Well, some of these things, the clue is right there in the name, from Latin root words. Nominal means in name. So nominal data would be something where there is no there's no numerical value to it whatsoever. Examples they gave here are gender, nationality, ethnicity. This is a type of qualitative data or categorical data. There's no math you can do to it. There's no numbers per se. Now, you might assign an arbitrary number to represent, nationality or ethnicity or language, where maybe for language 1 equals English, 2 equals Spanish, 3 equals French or whatever. But those numbers don't mean anything in a quantitative way. You're not gonna be able to do math to them. They're just a category. So that's what nominal data is. There's no difference automatically between the different values. The next one is ordinal. So this is where you have a representation that might be numerical. For example, first place, second place, third place. There's an order, or there's some sort of defining difference between them, but not necessarily something where you can compare them in a numerical way. First place in a race, second place in a race, third place in a race also has to factor in, the speed, or sorry, the time that they ran, right? You're not going to be able to automatically calculate a difference between first place and second place other than the rank that was assigned to them, right? And the suits in a deck of cards might have a rank order on highest to lowest value, right? With an ace probably at the top, depending on what game you're playing, king next, queen next, right? All the way down to a deuce, but they don't necessarily have anything you can do math to automatically. This ordinal data can also be when you have values that are comparing and contrasting two things, sick versus healthy. There's a difference there, but it's not necessarily a numerical difference there. Guilty versus innocent. It's two things that are different that can be ranked in order of, maybe weather, right? Weather has, sunny, cloudy, rainy, snowing, right? There's differences there, but no numerical differences. So that's ordinal. Interval data means there are numerical differences involved. Example they give here would be measuring temperature. So the differences here between interval and ratio is that in interval data, while there are meaningful measurable differences that are numerical, you can't necessarily do a math on that still. They aren't, the example given here is that 20 degrees Celsius isn't necessarily twice as hot as 10 degrees Celsius, right? The 0 point is kind of an arbitrary number made up and defined by whoever created that unit of measurement. So 20 isn't necessarily twice as much as 10 in that kind of suit. Same thing, latitude, longitude. 10 degrees north versus 30 degrees north, isn't 3 times less north than the other one, right? So there are meaningful measurable differences there that can be numerically calculated. You can perform some math on them, but not on a scale of comparison. Ratio, however, one difference could be twice as much as another. There is a discernible, scaled, measurable, sorry, not scaled, but there's a meaningful zero. There's the distance between them are well defined. And if you're doing any kind of statistical measurements on them, ratio measurements would probably be the one that you're using. All right, so let's move along to defining statistics. So statistics is just gathering, collecting, organizing, analyzing, interpreting, and presenting the data. It's not enough to just gather huge amounts of data. You need to organize it in a way that makes sense, right? That you can actually keep track of it. You analyze it to see, are the numbers actually telling me something? You interpret it, meaning, well, what is it telling me? And that requires more than just the raw numbers. It requires you to use your past experiences, your knowledge on the subject, performing computations to it, interpreting it, what does it mean, and then presenting the data. If you're analyzing data for a business purpose, it's really not enough to know what it means. You also have to get that knowledge to the decision makers. As the analyst, you're probably not the decision maker. You're probably a manager or a director or somebody in the C-suite, the CEO, CFO, COO, or the president, vice president. Somebody in a managerial or leadership position is making the decision, and you'll have to make sure that you can present that data in a way that makes sense to them. So well laid out and easy to discern quickly too. You only have so much time in those kind of meetings. So that's statistics. And I'll let you read the details on that, but that's the main summary of this chapter. So history of statistics, again, I'll let you go ahead and read that information right there. I don't think that needs interpreting, it just needs reading. And the purpose of this video isn't to read the book to you like a audiobook narrator, it's to kind of add to the learning. I don't think I can add anything to that. So what's the purpose of statistics? Well, we can make any kind of inferences, understand things better, make informed decisions is the biggest part of that. Whether that is in our personal lives or whether that's in playing of a board game or whether that's in making a decision for your business. So again, they go back and define sample and population again. The example here is that this cat food brand says that 8 out of 10 cat owners said that their cats preferred this brand to another leading brand. However, they went and only interviewed people who were already buying this brand. So the sample that they chose in order to represent the population of cat owners and people purchasing cat food was not biased. They'd already made a decision. So, they say their cat prefers it, but have they tried all of the different methods out? Have they done an actual study? Bias is a huge importance when it comes to the ethics of statistical analyses. If you're representing something, there needs to be a level of honesty and accuracy involved. And in this case, you've got a biased sample population. And so they're able to report this for marketing reasons. But who was the population or the sample that they interviewed on that, right? So something to think about when you get statistical data presented to you, especially in a marketing context. Inferential statistics. So inferring something is when you take information and you use it to arrive at a conclusion. And so you can make better decisions, intelligent guesses, right? And if you're inferring something, you don't necessarily have the answer, but you have enough clues to arrive at what is likely to be the answer, right? So think about a detective, data analysts could be called data detectives, right? They're trying to figure out what the information is telling them and arrive at a conclusion. They're not always going to be right, but they're going to be more accurate than just a blind guess, that's for sure. Inferential statistics, drawing conclusions about a population based on a sample size, right? Here we have a number of different results of samples of maybe a survey or something like that. If we plot these out on a map, we can see a scale as one goes up. There's a positive correlation between these two events, whatever they happen to be, right? So maybe this is maybe it's the number of people who go to a swimming pool when the weather gets warmer. So maybe this is in Celsius, and the number of people in whatever unit of measurement they show up. So you can make the inference based on the weather, the temperature today, how many people are likely to show up at your event, and you could staff accordingly. Types of data. So the two main types of data are going to be classified as either qualitative or quantitative. Quantitative just means numbers you can do math to. So if we look back at our data from earlier, all the way back up at nominal, ordinal, interval, and ratio, you could say that nominal and ordinal, while ordinal might have a number associated with it, nominal rarely does. Those things are qualitative. They are not something that you could do any kind of math to. So nominal and ordinal would fit under the qualitative type of data. They represent the qualities of it, but not necessarily a numerical, mathematical value. Whereas interval and ratio, there is math to be done there. You can compare those based on numerical values. You can do math to them. You can predict the temperature, right? That interval data. You could predict the temperature based on some other kind of aspects, the wind speed, or you could predict your turnout if you're in a outdoor space or indoor space based on the temperature. You can do math to them in that way. Primary, qualitative, and quantitative. So primary data, another thing to add in the mix. That just means that you have collected the data for one reason. Typically, you're the one who has gone out and collected it firsthand, or your team, or whatever. Secondary data is when somebody else has already done research and you're using that to also work with what you're working with, right? Oh, all this data is actually available already, so I'm going to use that for my study because it still makes sense for my study. But I wasn't the one who went out and got that. It wasn't originally for this case. It was for another case use, but it is applicable to mine as well. So that's the difference between primary and secondary data. Applying statistics. So collecting, organizing, analyzing, interpreting, and presenting the data. Kind of a retread on what we talked about: population, statistics, sample. All these have been talked about already. We talk about arithmetic mean. The word average is synonymous with an arithmetic mean, meaning you have you take all your values, you add them together, and then you divide by however many it was, however many numbers there were there. So if you have 10 people in a population, all right, you take a calculator, and the answers were, let's say it was you took the average age of a moviegoer for some movie, and you got 10 people, right? So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We divide that number by 10 because there's 10 values, and the average age of that moviegoer for this movie is 28.7 years old. So that's the arithmetic mean or average of your sample. Descriptive and inferential. So describing the data, you arrive at basically, you're not trying to make any kind of prediction on where the data might lead you into future outcomes. You're not trying to prescribe what to do. We're simply understanding the data. We're coming to a conclusion or understanding to describe what is represented here. Fundamentals of statistics is our next spot. We have the key terms yet again. Variable is introduced. So this is a quantity. This would be, if you're doing writing an equation, it's going to be a letter in that equation that just simply represents an unknown value or a series of possible values. We might have where X represents this and Y equals that, and Z equals this. It's anything we're adding into the equation that's representative of something else. It might be an unknown value, or it might be a value that is known in some other situation that we can plug into our equation. Right. So we've got define, once again, descriptive statistics. You're summarizing the data by describing what was observed. Inferential statistics is what conclusions can be drawn from it. Correlation, the idea of correlation is that one thing is related to the other. If you, here's an example, annual income shows that the age of death for poor people have shorter lives than affluent people, right? So your income could have a correlation on the age that you live in. Correlation, there is something there, but it's not necessarily the cause. Being poor isn't the cause of death. Being rich isn't the cause of living a long life. Plenty of very rich people have died early. Very poor people have lived long lives. One thing is not the cause of another thing, but there might be some sort of relationship there. For example, better access to healthcare because of your job that you have, better quality of life in terms of having access to fresh foods versus processed foods, or whatever the case may be. There's some correlation there, certainly, but it's not an automatic determination of the other. All right, so that's correlation. Critical thinking. So arriving at a proper conclusion takes an understanding of logic. What, because of this, then this. Is this always true? Is it sometimes true? Is it false? Thinking through the likelihood of things, thinking through, does this make sense? Not accepting things on face value, despite how trustworthy the source might be. But and I don't mean to be to say that critical thinking requires you to be skeptical, but by all means, no. But being able to draw a conclusion or solve a problem in a way that makes sense by working through it. As it says here, applying logical principles, requiring standards of evidence, rigorous standards of evidence, carefully reasoning it out, discussing claims, discussing belief, discussing issues in a way that you can draw a conclusion that just makes sense. Statistical literacy is just being able to understand statistics. So you need a baseline of understanding of statistics in order to be able to think critically. If you look at illness levels and you don't understand the rising levels of infection rates or something like that, it might cause a worse health crisis than otherwise if the population has a more better understanding of the statistics involved. Experimental design. So if you are trying to plan a design to run a statistical operation, there are typically variables involved. Often you'll have contrast between dependent and independent variables. An independent variable would be, what are we trying to what is it, what is causing something to occur in regards to what is happening in the dependent variable. The dependent variable means the outcome of that is dependent on the other variable or variables, right? So if I told you the turnout for, we'll go back to the pool situation, right? How many people show up at the pool today? Well, one of the variables might be the weather. One of them might be the wind speed. One might be, is it a holiday? Yes or no, right? You can turn that into a binary variable, 1, 0. And all those other variables are independent variables. They aren't dependent on other things in there, but they all make inferences and have some sort of correlation. It's usually not 0 with the dependent variable. The dependent variable relies on all those independent variables to arrive at that value. Something is causing this to happen. Something is causing the amount of people that show up to the pool that day to change. Is it just the weather? Is it the day of the week? Is it the temperature out? Is it, what is it that's causing this, right? Experiment. So experiment is any kind of test where you have controlled the conditions in some way with the looking to get the outcome of testing your thoughts, testing your theories, whatever your hypothesis is, trying to figure out the validity of something. You don't know what will happen if you try this. Now you know when you finish it or have a better understanding of it. You have a theory that this independent variable has an effect on this dependent variable. Let's get a bunch of data sets and plug it into some sort of regression formula and figure out if it does or not. Number of different types of experiments listed here. Comparison, you just when you're looking at one thing versus another. Randomization, you assign individuals to various groups and determine whether or not something happens when those things mix, replicating somebody else's experiment to find out if you can duplicate the results, to test whether it was accurate. Maybe there is some sort of question on whether the results were believable or not. You test yourself. If you want to figure out if the Earth is round or flat, you can measure that pretty easily. The curvature of the Earth right here on the ground. It's very easy to replicate that kind of experiment. Spoiler alert: the Earth is roundish. Not a perfectly sphere, but and so on. So a number of different possible types of experiments here. Random samples. So types of sampling involved where if you're trying to represent a population, a random sample, a completely random sample would be where you just grab information. I walk up to this person and do a survey, walk up to this person and do a survey. I'm not, only surveying people of one ethnicity or one gender or whatever the case is. There's no bias involved. There should be a less likelihood of any kind of error because it's more representative of the entire population. There's other ways to get sample data. It doesn't necessarily have to be random sampling. Simple random sampling would be just completely random. I think that's the end of the chapter. So again, just a kind of a brief overview. There's still going to be some of this you're going to need to read on your own, especially as you prepare for the quiz and the eventual final exam. You want to revisit this prior to that, and make sure you do read the other items in that module 1 folder. But if you have any questions on chapter 1, let me know, and we'll see you in chapter 2. Chapter 2 and module 2 will have our first of a few Excel challenges. So we'll have a couple of videos for you there. Thanks.